Hello my dear students, welcome back to Learn Physics. In today's video, we are going to discuss about the chapter Electric Charges and Fields. So last class we discussed about the what are the characteristics or properties of charges we learned, and that is quantization Q equals NE. That was the important formula which we learned, and conservation of charges, additivity of charges. While adding the two charges, we should include the positive and negative sign we should be included while we are adding the charges. So in today's class we are going to discuss about Coulomb's law. See, in Coulomb's law, if we are considering two charges, Q1 and Q2, separated by a distance r, then force between the charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. So F is proportional to Q1 Q2 by R square. So for changing the proportionality sign, multiplying with a constant, that constant is 1 by 4 pi epsilon 0 Q1 Q2 by R square. So here we can find out, see what is this 1 by 4 pi epsilon 0? I told you it's a constant. The value of 1 by 4 pi epsilon 0 is 9 into 10 to the power 9. That is the value of this 1 by 4 pi epsilon 0. In that, the value of epsilon 0 is, what is that? 8 point value of epsilon 0, 8.85 into 10 to the power minus 12 Coulomb square per Newton per meter square. This is unit you should remember. F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. In that we need to find out the formula for or unit of epsilon 0. Epsilon 0 equals 1 by 4 pi into Q1 Q2 by F R square. Q1 Q2 means it is Coulomb square. Coulomb into Coulomb, Coulomb square. Divided by F is Newton divided by R, unit is meter. So Coulomb square per Newton per meter square. That is the unit of epsilon 0. This is 10 to the power minus 12. 1 by 4 pi epsilon 0 is 9 into 10 to the power 9. That also don't forget. Now we need to find out what is the dimension of this epsilon 0. So how can we find out the dimension of epsilon 0? See here we know that F equals 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. 1 by 4 pi doesn't have any dimension, right? So epsilon 0 equals 1 by 4 pi into Q1 Q2 divided by R square. So for that, first you need to know what is the dimension of Q. Q equals IT. So I, we know the dimension of I is, dimension of Q equals dimension of I into T. This formula you know, right? Electric current I, what is the dimension of current? A. Time is T. So here the dimension of Q is A into T. Therefore, dimension of epsilon 0 you will get it as AT into AT. That is A square T square divided by, here F is there, FR square. Force, what is the dimension? M L T to the power minus 2 into L square. So when we are solving this, A square T square divided by M L cube T to the power minus 2. Here we will be getting it as M to the power minus 1, L to the power minus 3, T to the power minus 4, A square. This is how we will be finding out the dimension of epsilon 0. Clear? So this is the formula for finding out epsilon 0. And here what is Coulomb's law? Coulomb's law also very important. F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. Okay, now here we can consider the force between. See, we can the questions can be asked like, if the force between the charges is you can find if we are doubling the charges. Suppose Q1 and Q2. Q1 equals 2 Q1 and Q2 equals 2 Q2. What will be how the force will be affecting? Then F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. So So here it is doubling, this also doubling. 2 into 2 together 4 times the initial force. Okay, force will be increasing by 4 times the initial value, and if the distance between the charges is increasing, it will be 1 by 4 times. If the distance between them is doubling, what will happen? So the respective values you should substitute and find out. Clear? So this is how we will. Then next is unit of charge. Unit of charge we already learned it as Coulomb. Coulomb is the unit of charge, but in CGS system it will be represented in stat Coulomb. Okay, stat Coulomb is the CGS system. Franklin also will be given for this CGS system of unit. Okay, CGS system, stat Coulomb or Franklin. 1 Coulomb is given as 3 into 10 to the power 9 stat Coulomb. Stat Coulomb. Okay, 1 Coulomb is 3 into 10 to the power 9 stat Coulomb. This is how we will be representing the charges. What is the unit? Unit of charge. In SI system it is Coulomb, and in CGS system it is stat Coulomb. Next, we can find out the relative electrical permeability. How can we find out the relative electrical permeability? See here, F equals 1 by 4 pi epsilon 0. Epsilon 0 is the permittivity of free space. Permittivity of free space. Free space. Then epsilon R is the relative permittivity. Epsilon R is relative permittivity. Then we can represent epsilon. Permittivity of a medium is equal to epsilon 0 into epsilon R. This is the formula. This formula also please by heart and keep. And this for this force between different charges. See Q1, Q2, Q3 like that. N number of charges are there, and which are at a distance R1, R2, R3, etc. Rn from different points. Then to find out the net force acting on the system. Okay, net force acting on the origin, that like that we can find out by taking the superposition principle. What is meant by the superposition principle? It is the sum of all the forces acting on the system. Force acting on Q1, force acting on the origin O due to Q1, force acting on O due to Q2, due to Q3, all the forces we should add and find out the final answer. That is superposition principle. Okay, superposition principle, we will be finding it in that way. Next, the continuous distribution of charges. How can we find out the continuous distribution of charges? Continuous distribution of charges means, see here in the surface charge density. So surface charge density, sigma is the representation for surface charge density. Delta Q by delta S. Since it is surface, it is given by sigma equals delta Q by delta S. And linear charge density, that is represented by lambda delta Q divided by delta L. That is linear charge density. And then rho is the delta Q divided by delta V, volume charge density. So linear charge density, surface charge density, volume charge density. This and all we need to keep in mind. That is charge distribution. If the charge is distributed in a wire, then we can consider the linear charge density. It is distributed on a surface. On the surface alone, it is considered as the surface charge density. If it is distributed in a complete volume, if it is distributed, then we can consider the volume charge density. So for now, you should know what is meant by the surface charge density, volume charge density, and linear charge density. Okay, clear? So now I'll give you one question like this. See, force of attraction between 2 point charges placed at a distance d is F. So we are considering 2 point charges Q1 and Q2, which is at a distance d, as having force between them as F. What distance apart should they be kept in the same medium so that force between them is F by 3. What is the distance? We need to find out the new distance F F becomes, new force become 1/3 of initial force. How we can find out? Here F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by D square. Next is, now the new force is F by 3. 1 by 4 pi epsilon 0 Q1 Q2. There is no difference for these two charges, right? So Q1 into Q2 divided by D. New D is, we don't know, D dash square. Now I can divide these two equations, equation 1 and equation 2. Dividing 1 and 2. F by 3. Taking the reciprocal and multiplying, so we will get it as 3. 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0, Q1, Q2 will cancel. So while taking the reciprocal and multiplying, we will get it as D dash square divided by D square. So what is D dash square from here? D dash square equals 3D square. D dash will be equal to root 3 into D. So this is the formula. Okay. So this is how we will be finding out the new distance. Clear, children? So another question is 2 point charges 2 microcoulomb plus 2 microcoulomb. 2 point charges plus 2 microcoulomb plus 6 microcoulomb repel each other with a force of 12 Newton. Plus 2 microcoulomb plus 6 microcoulomb repel each other with a force of 12 Newton. If each is given an additional charge of minus 4 microcoulomb, what will be the new force? So here first charge will become equal to, we are giving an additional charge of minus 4 microcoulomb to each one. So plus 2, along with that I am adding minus 4. So together it is minus 2 microcoulomb. And the second charge became 6 plus minus 4. So together it became 2 microcoulomb. What will be the new force? We need to find out, right? So here F is equal to, we don't know the distance between them, right? So here initial force F is given as 12 Newton, that is equal to 1 by 4 pi epsilon 0. Initial charges are given 2 microcoulomb and 6 microcoulomb divided by D square. The new force will be equal to 1 by 4 pi epsilon 0 into minus 2 into 2 divided by, what is the distance will be remaining same. They are not telling the distance is changing. So when we are dividing these two equations, while we are dividing, F divided by F dash, 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 will get cancelled. D square and D square will be getting cancelled. So here 2 and 2 will get cancelled. Next minus 6 divided by 2 we will be getting. So here the answer is, here it is minus 3. Minus 3 you will be getting. So the new force F dash will be equal to F by minus 3. F we got it as 12 Newton divided by minus 3. The final answer is minus 4 Newton. So this is how we will be finding out the force acting between the charges. Okay, clear, children? So same way you can try to solve the numericals which is given in your in your textbook exercise. Numericals will be very important, so please try to solve that also. Okay, dears, so here we are going to do these questions. Here, is it visible for you? Visible, right? First one. Here first question is given, 1 stat coulomb equals dash coulomb. 1 coulomb equals, see, I already told you 1 coulomb equals 3 into 10 to the power 9 stat coulomb. Then what will be 1 stat coulomb? 1 stat coulomb equals 1 by 3 into 10 to the power 9. So 10 to the power minus 9. So the option D is correct. Okay, clear? So next is, which of the following is not an insulator? Here which is glass, rubber ebonite, human body. So all these points are given, which is not an insulator. In this, what human body is a very good conductor. That one we know, right? So it is a very good conductor. It is not at all an insulator. So here the answer is D, human body. Next, an object is charged when it has a charge imbalance, which means the object contains no electrons, object contains no protons, object contains equal number of electrons and protons, object contain unequal number of electrons and protons. When it has a charge imbalance, if charge is balanced, then both will be equal to neutral, right? Total charge will be equal to 0. Object contains only electrons, then we can't say it like that. Object contain unequal number of electrons and protons, then we can say there is a charge imbalance. Cause of charging is actual transfer of protons, actual transfer of electrons, actual transfer of neutrons, and none of the above. So what is the cause of charging? Actual transfer of electrons. Electrons only transferring from one position to another position, right? So next is, when a plastic comb is passed through dry hair, the charge acquired by the comb will always be, in yesterday's class we learned, it will be always negative. Plastic comb, when it is rubbing, if this plastic comb, instead of that, if we are using a wet comb, or we are combing the hair in a wet hair, okay, combing in a wet hair, will this static electricity will happen over there? No, it won't happen. Okay, out of glass and silk, work function of glasses, which one will be more, having more ability? That only it is asked. That is glasses smaller. Work function is smaller for glasses. The cause of quantization of charge is the transfer of electron, transfer of protons, the transfer of integral number of electrons. Quantization, it is the integral number of electrons. Next is, what is not true? It is not possible to create or destroy net charges carried by any isolated system. So this is true. It is not possible to create or destroy charges. That is true. And charges can be created or destroyed in equal and unlike pairs only. Equal and unlike pairs only. Yes, that also true only. Then this is true. Proper signs have to be used while adding the charges in a system. Yes, we need to add proper signs. Excess of electrons over protons in a body is responsible for positive charges of the body. Excess electrons is given negative charge, so it is false. Okay, so that is not correct. So the rest of the questions. Charge on a body which carries 200 excess electrons. 200 excess electrons are there. How can we find out the charge acting on the system of body? Q equals Ne. So Q equals 200 into 1.6 into 10 to the power minus 19. 200 into 1.6 is 3.2 so we will be getting 320 into 10 to the power minus 19. So the answer given is 3.2 into 10 to the power minus 17. Since it is positive, that is electrons, it has negative charge. So minus 3.2 into 10 to the power minus 17 Coulomb. The answer is C. Next is value of absolute electrical permittivity of free space. Absolute permittivity is 8.8 epsilon 0. The value of epsilon 0. Absolute electrical permittivity, that is permittivity of free space, that is 8.854 into 10 to the power minus 12 Newton meter square, Coulomb square per Newton per meter square. This is the final answer. Okay, so next is lighting is a common example for electric discharge. It is the common example for electric discharge through air. Value of charge on a body which carries 10 excess electrons is, how can we find out? Q equals Ne. N is 10 into 1.6 into 10 to the power minus 19. So we will be getting it as minus 1.6 into 10 to the power minus 18 we will get, since it is multiplying with the 10. Like charges will be repelling and unlike charges will be attracting each other. Positive, negative will be attracting. Charges acquired by the objects on rubbing against each other must be equal and opposite. Okay, should attract, right? Then it will be equal and opposite. Dash was first to show dash kind of charges. Okay, duafe, that one is not there in your textbook, it's not required. Okay, insulators are also called as dielectrics. Last class we told, right? Insulators are also known as dielectric. The cause of charging is dash of electrons from dash to dash. Transfer of electrons from one material to another material. Okay, so cause of charging is transfer of electrons from one material to another material. So this is not required. Charges can be created or destroyed in equal amounts, equal and unlike pairs only. Charges can be created or destroyed in equal and unlike pairs only. Okay, next is the value of electrostatic force constant in free space. Force constant in free space is 9 into 10 to the power 9. Now, Newton meter square per Coulomb square. Okay, this is a value of electrostatic force constant, that is K, 1 by 4 pi epsilon 0. What is the value of this electrostatic constant? Okay, clear children? So this is about the some of the MCQs which is I had taken from Pradeep publication book. So I hope this video is useful for you, and after completing the electrostatics we will be doing some more MCQs from other textbook also. Okay children, so happy learning and thank you for watching, and please don't forget to subscribe, like and share the channel if you like it. See you in the next video. Bye.